In this video, I'm going to show you how to differentiate functions using the rules of differentiation. So here's our first problem. We're given that there's a function f of x equals x cubed times natural log of x, and we want to compute f prime of x, the derivative. Now this function is a product of two other functions. It's the product of x cubed and natural log of x, so we can use the product rule to compute the derivative. The product rule just states that the derivative of a product of two functions, u and v, is equal to the derivative of u times v plus u times the derivative of v. And in our function f of x here, we'll have the first term, x cubed, that'll be u, and the second term, natural log of x, that'll be v. So putting this into the product rule, we have that the derivative of the product x cubed times natural log of x, the derivative of that is equal to the derivative of u, so let's just write as x cubed prime for now. We'll actually compute that derivative in a little bit. Then times v, so times natural log of x, and then plus u, so plus x cubed times v prime, and v is natural log of x, so we want to differentiate that. So let's go ahead and compute these derivatives. Derivative of x cubed, just using the power rule, all we have to do is bring down that exponent, 3, and so we do 3 times x to some power, and the power we get by decreasing that exponent, 3, by 1. So now it becomes 3x squared. So we've got that times natural log of x, and then plus our other term. Our other term is x cubed times the derivative of natural log of x, and the derivative of natural log is just 1 over x. So let's write that down, 1 over x. And now it's just a matter of simplifying this expression here, so let's go ahead and do that. We've got 3x squared natural log of x. That can't be simplified anymore, but the second term here, x cubed times 1 over x, can be simplified. X cubed over x is just x squared. And just to clean things up a bit, let's go ahead and factor out any common terms. We see that there's an x squared in both terms, so let's factor that out. So we have x squared times the quantity 3 natural log of x plus 1. So there we go. There is our derivative. Alright, next problem. We're given a new function, f of x is equal to e to the x over sine of x, and we want to compute the derivative f prime of x. So here our function is actually a fraction. Numerator is e to x, denominator is sine of x, and we've got a derivative rule for dealing with fractions. It's called the quotient rule, and it tells us that the derivative of the quotient u over v is equal to u prime v minus u v prime all over v squared. So let's go ahead and look to our function. What's u and what's v? Well, u is just the numerator, e to the x, so let's draw a little arrow, that's u. And then v is just the denominator, which is sine x, so this is v. Now it's just a matter of plugging all this information into the formula. U is e to the x, and then over v, so over sine of x. We differentiate that, and here's what we get. First we have a u prime, so let's just write u is e to the x, and we want to differentiate that, prime that. We'll take care of that in the next step. Right now let's just go ahead and write everything down. Okay, so that's times v, so times sine of x, and then minus u times v prime, so minus e to the x times sine x prime. And that's all over v squared, so all over sine of x squared. And now it's just a matter of computing this expression here. Alright, so to start off, what's the derivative of e to the x? Well, that's easy. E to the x, the derivative of that is just itself, e to the x. So we've got e to the x times sine of x, and then minus e to the x times the derivative of sine of x. And the derivative of sine is cosine. So minus e to the x times cosine of x. And that's all over sine of x squared. And we can write sine of x squared as sine squared of x. So lastly, let's just go ahead and factor out anything that we can. We see an e to the x in both terms in the numerator. So let's go ahead and factor out an e to the x. And then we'll have e to the x times the quantity sine of x minus cosine of x. And that's all over sine squared of x. And there we go. There is our derivative function. Here's another example. We're given that our function f of x is defined by 3 to the power of tangent x plus cosine x, and we want to compute the derivative f prime of x. Alright, so this is a pretty complicated function. We've got an exponential function, 3 to some exponent, combined with this function tangent x plus cosine x, which represents the exponent. And how do we deal with this kind of composition of functions when we're differentiating? Well, we just use the chain rule. The chain rule says that the derivative of a composition f of g of x is equal to f prime, the derivative of f evaluated at g of x, and then times the derivative g prime of x. Alright, so really we know what f of x is, but what do we want to use as g of x to simplify the situation as much as possible? Why don't we just let the entire exponent here, tangent x plus cosine x, be g of x? So we'll go ahead and write that off to the side very explicitly. G of x is equal to tangent x plus cosine x. And then just to keep notation very easy, let's write f of x again, but let's actually write it as f of g, because all we care about is what the function f is doing to our function g of x. Now f of g is just taking that function g of x and putting it in an exponent of 3. So f of g is just 3 to the power of g. Just to be clear, g stands for g of x, but we're just writing g so that the notation becomes a lot cleaner. Alright, so now that we've got f and g, let's go ahead and stick that into the chain rule. So we have that derivative d over dx of f of g of x, so of 3 to the power of g, g is just tangent x plus cosine x, derivative of that is equal to f prime of g of x, so really the prime of 3 to the g, that's f, and then times g prime of x, so times the prime of tangent x plus cosine x prime. Alright, so let's go ahead and evaluate this. What's the derivative of 3 to the g with respect to g? Well, remember that any power raised to the variable, the derivative of that is pretty similar to the derivative of the exponential function, e to a power. It stays mostly the same, so we have this 3 to the g term, but when the base is something other than e, we also have to multiply by the natural log of the base. So we have to multiply by natural log of 3. Alright, and then moving on, the derivative of tangent x plus cosine x, what is that? Well, the derivative of tangent x is just secant squared x. And the derivative of cosine x is negative sine x. So we have a minus sine x. Alright, so we're nearly done, but there's still one thing left to do. Look, we've got a 3 to the power of g, and we want to write the entire expression in terms of x. So we want to substitute in for that g. We'll put our function g of x equals tangent x plus cosine x into that exponent. So let's write down the final result. The final result is 3 to the power of g. G is just tangent x plus cosine x. That times natural log of 3, and then times secant squared x minus sine x. And there we go. We've got it. There is our derivative. So now we know how to differentiate functions using the rules of differentiation. And in the future, we'll continue learning cool techniques for differentiating complicated functions, including inverse functions and functions that are given implicitly in some kind of equation.